Welcome at Lois. The last video we saw about Pascal Triangle, what is NCR, certain properties regarding NCR. So it's going to be a great help if we continue to do some problems based on these properties and also identify how to recognize these properties being used in problems. Question number one, we are told for 2 being less than or equal to R, less than or equal to N, what is the value of NCR plus 2 times NCR minus 1 plus NCR minus 2. We can identify here, we are not going to get a numerical value, but we are just going to get a simplified format. So which property will be useful here? So that we need to identify. So out of the 5 properties that I had already written on the screen, you can identify the 5th property is where you are adding the binomial coefficient like NCR and CR plus 1. I told you it's like adding 2 consecutive quotients, R quotient and R plus 1 quotient. So that will be useful here, provided that the coefficient here is same. But here the NCR term, NCR minus 2 term, they don't seem to be consecutive terms. But this NCR and NCR minus 1, they seem to be the consecutive ones. So, but the only problem is this coefficient 2 is there. So from that we understand we can break this and write as NCR minus 1 plus NCR minus 1 plus NCR minus 2. Here you have NCR. Now you see what you learned in the previous property that the position R and position R plus 1, consecutive position in the same row n is being added up to get to the next row. Next row to n will be n plus 1 and the greater position. So here between R and R minus 1, the greater position is R and the next row to n will be n plus 1. So you have n plus 1 CR. Here again between R minus 1 and R minus 2, the greater position will be R minus 1 and the next row to n will be n plus 1. You'll have n plus 1 C, R minus 1, that's getting added up. Again, here between the greater portion between R and R minus 1 will be R. And the next row to n plus 1 will be n plus 2. The answer for this question is n plus 2 the R. So hope you are able to recognize and identify how you are able to use that property effectively. So that's the kind of question that they'll probably come out or ask in WITSAT, WBJE kind of exams. The next question. So look at this. Polygon has 44 diagonals. Find number of its sides. Find number of its sides. That's a question. So what is a diagonal in a polygon? Connecting a vertex to the non-adjacent vertices is called as a diagonal. As an example, I'll show you. If I'm taking a pentagon, so this particular vertex, let me call it as A, it's already adjacent to vertex B as well as vertex C. So connecting to them will create only sides of the polygon, not the diagonals. But if I connect A to C and A to D, they will be called as diagonals. So for every vertex, there is going to be 2 adjacent vertices and the other things will be non-adjacent. So there are n vertices in a n-sided polygon. For each vertex, there will be 2 adjacent vertices and remaining n minus 2 non-adjacent ones. Okay. So you have to be very cautious about this. Now, if I choose a vertex A, I have to choose the remaining. So the number of ways for me to choose that single vertex is going to be n options for choosing that. Okay. And for each of that, so it's like NC1. You are choosing one vertex at a moment. from n available vertices. And then for each of them, you have n minus 2 options to choose from to connect to the non-adjacent vertices. That's like for that vertex that being chosen, the n minus 2, n minus 3 altogether, because inclusive of that particular vertex A, say there are n minus 3 vertices from which you are going to choose one vertex. So nc1 into n minus 3 c1. So this product will give us the diagonals. Now there is one more thing. So AC is a diagonal, CA is also a diagonal, but we cannot count them as two different diagonals. We have to count them as only one diagonal. So this total product count should also be divided by 2 to give us the total number of vertices. So this is given in the question as equal to 44. So NC1 by NCR formula, it will open up as n. N minus 3 C1 will also open up as n minus 3. So n into n minus 3 is becoming 88. So we can easily identify it's becoming quadratic. We can just solve this, get the value of n. So n square minus 3n minus 88 equal to 0. So this will give us n minus 11 into n plus 8 equal to 0. So that tells us indirectly n has to be equal to 11. So 11-sided polygon will have 44 diagonals. So some people would have smartly recognized here itself. That is, it looks like 11 into 8, which is 88. Hope you enjoyed that question. We move on to question 3. Every one of the 10 available lamps can be switched on to illuminate a certain all. Question is the total number of ways in which a hall can be illuminated. So they have not given us any specific ordering of the light and all. So there are 10 lamps. So you can actually switch on all the 10 lamps. So that will be 10C10. You have 10 available lamps and all the 10 can be switched on. Or out of the 10 lamps, you can choose just 9. Or of the 10 lamps, you can just choose 8. 10 lamps, you can just choose 7. So like that, this goes on 10C6, 10C5, 10C4, 10C3, 10C2, 10C1. But and also they are all success cases. So we need to add them up. But we remember a property that we learned in the last session about this kind of an addition up. That means this reminds us these are the values of the Pascal triangle in the 10th row. And we know if all the elements are being added up, the value will become equal to 2 power 10. So, but there is some element which is missed here. You know, that is nothing but 10C0 is missed. But 10C0 is the case where you don't eliminate even one lamp. Even if you don't eliminate even one lamp, then the all cannot get eliminated. So that's why that particular case was being not considered. So what I'm going to do is I'm going to insert that 10C0 term just for using that particular property. I'm inserting plus 10C0, but since it should not be inserted, I'm also removing it. So through that property, you will understand if all the elements of the 10th row are being added up, the resultant of that is 2 power 10 and 10C0 value will become 1. 2 power 10 is 1024. 1024 minus 1 gives you 1023. So 1023 ways are there possible to eliminate that all. Hope you enjoyed this video. Like and subscribe.